Hello, everyone. Today I want to share an interesting research SWE Lancer. This is a benchmark dataset that directly links AI programming capabilities with real economic value. In this dataset, the most powerful AI model Claude 3.5 Sonnet. In tasks worth $500,000 completed 26.2% of individual development tasks and 44.9% of management tasks, earning a total of over $200,000 in revenue. This research comes from a recently published paper by OpenAI on AR14. Let's first understand the characteristics of this dataset. SWE Lancer is a dataset specifically designed to evaluate software engineering capabilities. Its data source is very unique. All tasks come from Expensify's open source and commercial code repositories. Expensify is a publicly traded company with a market capitalization of approximately $300 million. And it has over 12 million users, so these tasks are real and have commercial value. All these tasks are freelancer projects posted through the Upwork platform, written using JavaScript and TypeScript. Each task has a clear payment amount, with a very wide range. The simplest tasks may only require a few $100s, while the most complex tasks can pay up to $32,000. That it is particularly important to emphasize that these amounts are not estimates or speculations by researchers, but are the actual amounts Expensify paid to freelancers who completed the tasks. This ensures a real market correspondence between task, difficulty, and payment. In terms of task types, SWE Lancer covers multiple fields. Client application logic accounts for 70 to 75%, UI/UX development accounts for 16-22%, server-side logic accounts for 5-7%, system quality and reliability tasks, as well as infrastructure/DevOps tasks, each account for less than 1%. In terms of the nature of the work, bug fixes dominate, accounting for 87-93%. New features or enhancements account for 5-9%, while maintenance, QA, testing, or reliability improvements account for 1-4%. An important innovation of this dataset is the evaluation method. Unlike traditional programming benchmarks, SWE Lancer uses end-to-end tests handwritten by professional software engineers to evaluate the model's performance. This testing method is closer to real-world software development scenarios and is harder for models to exploit. For example, in a $1,000 task, the bug of inconsistent avatar display needs to be fixed. Traditional unit tests may only confirm whether each function works correctly. But end-to-end tests simulate the complete user operation process, including logging in, uploading avatars, interacting with other accounts, etc., to test the functionality more comprehensively. Another feature of SWE Lancer is the difficulty of tasks. The research team curated a public evaluation dataset called Diamond from the complete dataset. This dataset contains high-quality tasks worth over $500,000 in this Diamond dataset. Each task is quite challenging, on average. Each task takes 26 days to solve on GitHub and generates 47 comments, which often include discussions of multiple different solutions. From a code modification perspective, individual development tasks require modifying 2 files and 69 lines of code on average, while management tasks require technical leads to choose between 4 to 5 different technical proposals. In terms of evaluation results, the research team tested several top AI models, including OpenAI's GPT-4o August 2024 version, OpenAI's O1 model, using the high reasoning setting, and Anthropic's Claude 3.5 Sonnet. The best performer was Claude 3.5 Sonnet. But there is still significant room for improvement. Although the pass rate on management tasks was close to 45%, the pass rate on actual programming tasks was only 26.2%. In the complete SWE Lancer dataset, Claude 3.5 Sonnet earned over $400,000 in tasks worth $1 million in total. While this number looks good, it also means it couldn't complete nearly 60% of the tasks. In comparison, GPT-4's pass rate was 8.0%. The O1 model achieved a pass rate of 16.5% under high inference settings. These results indicate that current AI models, when handling real-world software engineering tasks, are not yet sufficient to completely replace human developers. Researchers also discovered some interesting patterns. First, the model performed differently across different price ranges. In simple tasks under $500, the model had relatively high pass rates. However, In complex tasks over $2,000, the pass rates dropped significantly. Second, when the model was allowed multiple attempts, pass at K, the success rate increased significantly. For example, for the GPT-4o model, when 6 attempts were allowed, its pass rate nearly doubled. Third, increasing reasoning time, test time compute, also improve model performance, especially when handling more complex, higher-paying tasks. Researchers found that the best-performing models are often effective at using tools and good at quickly identifying problems. They can quickly locate relevant code files and functions through keyword searches at a speed that even surpasses human developers. However, they often struggle with understanding cross-component or multi-file issues, resulting in solutions that are not comprehensive or accurate enough. For example, in a task that requires modifying both front-end display and back-end validation logic, models can typically only solve part of the problem. This suggests that AI models might be more suitable as auxiliary tools in software development, rather than completely replacing human developers. Generally speaking, SWE Lancer for the first time links AI programming capabilities with actual economic value, providing a more realistic perspective for evaluating AI capabilities in software development. Although this benchmark is currently more suitable for predicting AI's impact on freelance development, it helps us better understand the advantages and limitations of AI models, providing important references for future applications.